Hello, in this video I want to look at the distributive property. So when we look at the distributive property, what we mean is that we might have something such as, let's just have like a real number a multiplied by b plus c. So the distributive property is essentially such that you're just distributing that real number over the addition of the two real numbers b and c. So what that would give you is the following. It gives you a times b plus a times c. And then similarly, you have that, the same thing would work for subtraction. If you had a multiplied by b minus c, it would give you the same thing if you distribute the a over the subtraction. So you have a multiplied by b minus a multiplied by c. Okay, now similarly this would work if we were to reverse the distribution or the multiplication. So for instance, if I have b plus c multiplied by a, then you would expect the same exact thing where you have b times a plus c times a, but then the multiplication actually is commutative, so you have a times b plus a times c, which is the exact same thing, which would essentially mean that this is the same as a multiplied by b plus c. Okay, but let's go ahead and just look at some examples of where we use the distributive property. So for example, let's say that we have 3 multiplied by x plus y. Okay, so if we want to evaluate using the distributive property, then in that case, all that we would need to do is really just distribute the 3 to both x and y. So if we do that, then okay, we have 3 multiplied by x plus 3 multiplied by y. But these two terms are unlike, so in that case, there's nothing else left to do. So we just have 3x plus y. Now, similarly, we can actually reverse the distributive property. So what I mean by that, for instance, is let's say that we have 7x plus 21 and we want to reverse the process. Well, by reversing the process, we mean that we would basically be rewriting this as 7x, so 7 times x, plus, well, 21 can be rewritten as 7 times 3, of which by reversing, we mean that we just rewrite this as 7 times x plus 3. And then that would be it for that example, like whenever you're trying to reverse the distributive property. Now, let's say that, for example, that you have an expression that involves more terms and more of the use of the distributive property. So let's say that you have 3 times 2x minus 5, and that this is going to be plus 5 multiplied by 3x plus 6. Okay, so we want to simplify this by using the distributive property. So in any case, that just means that we have to go ahead and multiply the 3 and multiply the 5 respectively. So we have that, 3 times that and 3 times that. And then we have 5 times that, and then 5 times this. Okay, so we have 3 multiplied by 2x plus 3. Actually, that's not a plus, right? That should be a minus. Yeah, sorry. So we have minus 3 times 5, and then we have plus 5 times 3x plus 5 times 6. Okay, well, let's try to simplify this even further. So we have 6x, okay, we have minus 15, and then we have plus 15x, and then we have plus 30. Okay, well, let's group the like terms together. So we have 6x plus 15x, and then let's go ahead and say we have negative 15 plus 30. Okay, so this will simplify to 21x, 21x plus 15, and then that would be it. Now, interestingly enough, you could probably rewrite this by sort of doing the reverse distributive, which in any case might say that, you know, you could take out a 3 and then say that that's going to be 7x plus 5. But that's only if they want you to reverse the distributive property. Okay, so how about you go ahead and you try the following expression where you have to simplify and combine like terms. So you have negative 2t plus 7 plus 3 multiplied by 2t plus 4, and then you have minus 2t. Take a moment and see if you can simplify this using the distributive property and also combining like terms. Once you do that, then you can fair enough say that, you know, you understand the distributive property. Okay, so alright, so this is a little bit of you try. So hopefully you got the right answer. Now notice that in a way this is almost like negative, or it is actually negative 1. So it's like there's an imaginary negative 1. So essentially you just need to distribute the negative 1 over the addition. So that's going to be minus 2t minus 7 plus 6t plus 12 minus 2t. But if you group all the terms together, then in that case you have 6t minus 2t minus 2t, and then you have minus 7 plus 12. Now, using, let's say that, okay, we have to combine like terms. Well, if we go ahead and we just say that 6t minus 2t is 4t, and then you have 4t minus 2t is just 2t, then that'll work out. Then you also have minus 7 plus 12 is just positive 5, or plus 5. So we have that it simplifies to 2t plus 5.